expenditure of public monies be made public.
The rest of the construction budget was spent on carving that marble. In that sense, the workplace today, as in ancient times, is less a construction site and more a sculptor's studio.
We have, in some cases, to form a new drum from 100 different pieces. That is a very, very difficult work.
Here, the restorers recovered a part of an original capital, but were missing the pieces to fit around it. They had to carve them by hand from the newly quarried Pentelic marble. They start by making a plaster cast of a missing piece. Then they use this ancient mason's device called a pantograph to record the three-dimensional shape of the cast and transfer it point by point to the new marble.
It's a very traditional technique. Even the Romans were using the same device to copy the sculptures in antiquity.
Once a new piece is completed, they can join it with an old. But will their new piece fit? It doesn't. It's just millimeters off. The moderns will borrow a technique used by the ancients for fitting together two new blocks. They coat the inside surface with red clay.
In the points it doesn't fit, it leaves white marks. Where the clay goes white, they have to carve it a little bit more and test it again until they have no marks when they are closing the two pieces.
The operation is repeated dozens of times until the new marble exactly matches the ancient broken surface. But even when they succeed, there's still the challenge of fitting the restored pieces precisely back into place. After months of painstaking work, drum number 14192 doesn't quite make it.
As you see here, we have a small ancient fragment. We built around it with the new addition. Now we are going to move it and take it down to the workshop.
Just a few millimeters of excess new white marble has to be cut from the base at ever so slight an angle to match the precision of the original blocks.
These differences of 1 or 2 millimeters is just a miracle. You can't believe that you have so small differences.
And here lies the Parthenon's central mystery. How did the ancients sculpt it with such precision and speed?
Ήταν βλέποντας εδώ ένα σπόνδυλο του προνάου, πάνω στον οποίο υπήρχαν αυτές οι γραμμές.
Etched into the marble itself, Manolis Koris finds a clue.
Καταλάβετε τι είναι αυτό? Το έχετε δει ποτέ σας? Όχι. Δεν έχετε δει ποτέ αυτό?
Koris made an extensive study of the relationship between tool marks and the kind of tool and force necessary to produce them.
Το χέρι.
From these marks, he reconstructed a type of chisel lost since antiquity. The marks led Koris to identify a range of tools that reflect centuries of expertise in metallurgy, enabling the Greeks to produce sharper and more durable tools than we have today.
Βέβαια, ναι. Αλλάζουν οι γωνίες όλες γύρω. Δηλαδή πάει στις καμπύλες. Ναι, βέβαια. Φαίνεται που μπαίνει ο άλλος μετά. Κάθεται σε αυτό το σημείο.
And from minute differences in the chisel marks, Koris can even identify the distinctive workmanship of about 200 different stonemasons. They were recruited from throughout the Greek islands and would have had many different systems of measurement. Without a common standard, coordinating this workforce would have been a logistical nightmare. How did they do it? One answer lies on the island of Salamis, not far from Athens. Here, discovered on a church wall, was a stone carving. Today, it is in the Piraeus Museum. Architect Mark Wilson Jones believes the enigmatic Salamis stone, depicting an arm, hands, and feet, may be a conversion table for the different measuring systems, Doric, Ionic, and Common.
This is a tracing I've done that shows the stone, and you can immediately see how the main measures work. We have this foot rule here, that's 327 millimeters, more or less, the Doric foot. And here you have a foot imprint that's roughly 307 millimeter long foot, which we tend to call the common foot. And there are in fact other feet. For example, this dimension here is one Ionic foot. So there's a kind of whole network of different interrelated measurements here.
The Salamis stone represents all the competing ancient Greek measurements: the Doric foot, the Ionic foot, and for the first time, the common foot, virtually the same measurement we use today. Wilson Jones finds evidence of all three measuring systems in the height of the Parthenon.
That distance is at one at the same time 45 Doric feet, that's the ruler on the relief. It's also 48 common feet, which is the foot imprint, and it's 50 Ionic feet, all at the same time. And these are quite exact correspondences.
So the Salamis stone may have provided a simple way for ancient workers from different places to calibrate their rulers and cross-reference different units of measurement. But the Salamis stone may also be a clue to how the ancient Greeks were using the human body to create what we now regard as ideal proportions.
What's extraordinary about this is that at the same time as being a practical device, it's also a kind of model of theory, architectural theory. The perfect ideal human body designed by nature is a kind of paradigm for how architects should design temples.
Among the first to record that Greek temples were based on the ideal human body was the Roman architect Marcus Vitruvius. He studied the proportions of temples like the Parthenon in the 1st century BCE, 400 years after it was built.
Vitruvius' work gives us the overall frame which is necessary to understand the system of proportions of the Parthenon.
According to Vitruvius, Greek architects believed in an objective basis of beauty that mirrors the proportions of an ideal human body. They observed, among many examples, that the span from fingertip to fingertip is a fixed ratio to total height. And height is a fixed ratio to the distance between the navel and the foot. 2,000 years after the Parthenon, another artist was also searching for an objective basis of beauty.
This is a very famous image. It's drawn by Leonardo da Vinci in the Renaissance, and it's based on Vitruvius' description of the ideal human body, and it encapsulates this idea of its theoretical importance. And what's really interesting for us is that when we superimpose the Salamis relief on this drawing, we see that there's a remarkable correspondence. There are differences, but it's the same principle. You have the same interest in the anthropomorphic principle of giving a kind of sacred, fundamental justification for these measures.
Da Vinci's ideal Renaissance man famously stands in a circle surrounded by a square. Da Vinci named this image Vitruvian Man, after the Roman architect. The ratio of the radius of the circle to a side of the square is 1 to 1.6. That ratio is sometimes attributed to the Greek mathematician Pythagoras, who lived 100 years before the building of the Parthenon.